home stretch with the normal distribution. We'll pick up other couple different distributions as well. But here we got, when we have a normal distribution, we're given the mean and the standard deviation. It has to be given to us. I guess they could give us the raw data, but fortunately they don't. So our mean, our standard deviation, and then we want to find the probability of being between these two endpoints. So I'll start off with the quick way. I'll also show how we can use the function itself to graph these and do this part, and then which leads you into the tables, which you're welcome to use those as well. So first of all, the quick and easy way, you have your graphing calculator. Again, each graphing calculator works differently, but for here, we have this nice feature under distributions. So second vars, right? That's the distribution button. Oh, it has a draw. I had never seen this. We'll try that. Let's. The easy way is here, going to normal CDF. Okay. So we go into here. We put in the lower limit, which in this case is going to be 30. And then the upper limit, which is 43. And then down here, we put in our mean and our standard deviation, which in this case is 31 and 20 for the standard deviation, right? So we put those two values in. Hopefully I'm in the right place because this is going to paste it. I can't remember if I was, oh good, I'm in the, so you want to start from the main screen of the calculator, not being in a place where it's going to graph, because otherwise you don't get it. So it's 0.2456. We'll round, 4 decimal place, we'll round that up 0.2457. 2457. And my work would be something like I use the CDF normal distribution. It does this sometimes on me, but there we go. Distribution. Okay. Let's go back to that because a lot of times it's good to see the picture. I just noticed they had this draw on it, so let's see what happens if we go second distribution and we want to draw this. We want to shade the normal. We can do that right here. So this is really cool. The lower limit is 30. The upper limit is 43. Our mean, so this is set up for standard normal, but we'll go ahead and do this with our mean of 31. It makes it much easier. And 20. So I don't, it's going to graph it for us, it's going to draw it in blue. With this, you could change the color if you want, but so 30. Probably have to do something with my window. Let's see. Gives me the area. Oh yeah, it's here. So let's do the window. Also, let's go here. Let's clear. We don't need this anymore, so we'll get that out of there. Remembering our standard deviations goes from like -3 to +3. So I'm going to go -4 to 4. Wait. Oh, this is a mean of 31. Standard deviation of 20. So that would be, I have to think too much maybe for this. 3 times 20 is 60. Subtract that from 31, so about negative, actually 3 is 60, so subtract 60 from 30, so I'm going to go to -30. X will be -30 all the way to 30 plus 60 is going to be 90, 91. That's close enough. I think this is the problem. And then remember, it's all going to add to 1, so it's going to be a very narrow, the line was at the bottom. I'm going to have the maximum, say, at 0.5. It's just a half the Y max is that there. I still think we're not going to see too much because this whole thing. So there it is. What I have to do is come back here, go over to draw, and shade the normal curve. We'll put in our values of 30, 43, and a mean of 31. So that should be about middle. 20 will be our standard deviation. Yes, you can kind of see it, but you can see also I need my Y maximum to be much smaller. But here's the value we get, 0.2456. That would round up to 7. What did we get? Yeah, exactly what we got. Rounded it up to 7. And you can kind of see it. Again, changing the window to maybe a lot less than this, maybe 0.1. Let's go with that. And then now when we go and have it do it, again, it looks like we each time have to enter all the values from 30, 43, 31, this is 20. And it just, you'll see, you'll get a better view of it now. It looks like a normal curve. And there's our values, the low. So anyway, an extra feature if you'd like. When we have the standard normal curve, that's where it's a little better because you can just go basically from -4 to +4, have the height of about 0.5, and you'll just be fine. We'll leave it at that. That was the other way I was going to show you. The other way, we could turn these into what are called z-scores, and so I'll do that one. If you don't want to see it, you can head out now. But let's do this one just so it's helpful for everybody. So you could calculate the z-score of 30. And remember that formula is you take your x value minus the mean divided by the standard deviation. So in this case, it would be 30 minus 31 over 20. That would be one z-score. And I'll just do it on my handheld calculator. It's a little quicker this way. 30 minus 31 is -1, and then divide by 20, it's going to be negative 0.05. So that's one z value. So I'll call that z1. And then z2, the upper end, is going to be 43 minus 31 over 20. And that's going to give us 0.6 or 0.6. So then we could just use the standard normal and get the probability from negative 0.05 is less than or equal to x is less than or equal to 0.6. We could do this one. And again, if we're using, that's how I would maybe do with this one. This is where I can actually graph this. This is going to give me, this one is built with a mean of 0 and a standard deviation of 1, which is what the standard score is. So I'm going to turn that on. I'm going to set my window to go from -4, it's 4 standard deviations, to +4 standard deviations. So I'll see the whole curve, and I'll put it as a max of 0.5. I think you'll probably do 0.25 and you'll be fine. We're going to graph that, and there you see our normal curve, and then you can use this general process of getting the integral of that curve from the two values. So the lower end is negative 0.05, and the upper end is 0.6, or just 0.6. There's our number, 0.2457 if we round it up, and this shows us the picture of what got shaded. That's what we're looking for. So a couple different ways to do those. Find the one that works best for you, and again, we'll forward.